Welcome back to this ever-changed Devstream. How's everybody doing tonight? Chat, as you can see, I have made something horrible. What's up, LRC? Haven't seen you in a while. Yes. Oh man, the distortion. Fallout Pip-Boy. What's up, Yuncha? What's up, Pony Bro? Honestly, I made this as a shit post, but for some reason people wanted it, so I don't know. Oh yeah, what kind of gadgets did you get? That's enough of that. I'm going to yeet this into the void, where it belongs. So, as you can probably see from the title, we're going to be doing some experimentation with the 3D models of the game. Icarus has sent me the extracted model for Lloyd, which is going to contain the Dragon Buster. I'm just going to grab that file here. Let's see. Okay, so we've got 3D model. Now, DAE is a massive XML-based file format that is honestly kind of awful, but up until fairly recently, we kind of thought that that's what we were going to be using for model replacement because that was kind of like one of the standards. So that's what Doom built all his tools to use. And now we find out that they are deprecating that file format. So he's going to need to figure something else out. However, for the time being, we are going to use a library to import this into the game and just mess around with it and see what we can do. What's up, Ninchi? I mean, you might be able to LRC. We do have Linux ARM builds, so I assume that that's what runs on it. Okay, so first off, we need. I don't know who remembers this and who doesn't, but long ago, we messed around with importing some 3D models from Ocarina of Time into Legend of Dragoon on like a much older dev stream. So buried somewhere in here, I do have some very old code for loading these models. If we can find it. Let's see. Unless I just completely yeeted that code because it was garbage. That's entirely possible too. Let's take a look. Have you ever wanted to fist fight 45 Kiwis? Yeah, I don't think that's it. Icarus, do you remember where I put that DAE loading code ages ago? We might just write some new code, because it's not exactly complicated. I don't think it's in any of these. Yeah, anyway, so we are using a library called ASIMP. That is the actual name. It is a universal asset importer. We're just gonna pop open their documentation here and take a look. Alright, so we've got the Lloyd model here. What's up, Eric? How's it going? Are you feeding steak to the cats? Liv, say hi to everybody.
Hi, everybody.
I don't know if you can hear. You might have.
Hi.
There you go. You picked up that time. Eric says hi, Liv.
Eric.
Do we have it pulled in right now? Okay, so we'll just pop it, open the LWJGL stuff, and grab ASIMP. Yeah, it should just be that. I think it's just gonna be this. Let's see if this works. The people want to live cameo. She is shaking her head aggressively. I don't know if a live cameo is gonna happen. No, we don't have any ass imps. It would help if I spelled it right, apparently. Yep. Ass uno. Let's try that again. There we go. Cool. What kind of stuff do we have here? Read, no. Import file, that sounds promising. Is Liv going to cameo? Oh my god, it's a sideways Liv. Okay, she's gone. No more Liv. Okay, I think we can use this overload and just give it Sloyd.dae. Now what do we have for flags? We're just going to use no flags for now and hope for the best. Um, I have no idea how to use this library, so we're just gonna kinda go for it here. What does this scene have? Has animations, cameras, flags, meshes. Okay. Presumably meshes is what we want. Yeah, what's the worst that can happen? Um, Number of meshes. We're gonna start very basic, just importing the 3D model, no textures or anything. Um, Presumably, we need to create this from that pointer buffer. Now the question is how? Okay, meshes. Defined by a series of data channels. Yada yada yada. Only channels guaranteed to be always present are vertices and faces. That makes sense. We don't have bones because these are LOD models. Really pretty light on the examples. Yeah, that's just what we were looking at there. I assume developer guide is just for people who are working on this. Yeah, let's see if there's any LWJGL specific information. Okay, we're loading materials, loading meshes, AI mesh.create. Okay, that is kind of what I figured. It was on the right track. Yeah, we create, we pass it in the pointer buffer index from the scene. Meshes.get. We should, I'm gonna put on some music so it's just not me rambling and typing. Media player. How's the audio level? Too loud, too quiet? Presumably faces and vertices are all we are going to need to start with. Okay, perfect. Sounds good. Mesh dots. Vertices. Vertices is also a buffer. I assume that they're going to be AI vector 3Ds. What's up, Chocolate? Oh, time you showed up. Okay, vertices. That is what we are looking for. Yeah, AI vector 3D. That is exactly what we expected. So we can start building a mesh that can actually be rendered by the render engine. We'll use the poly builder. Call it Lloyd. And it's going to be GL triangles mode. Well, you're here now. Final vector 3D buffer vertices mesh dot vertices and while there are vertices remaining, we are gonna add them. Actually, no. We probably need to do this in faces. We should have mesh dot faces. That gives us a AI face buffer. While we still have faces, Not a single flying one. I guess we are truly unique. What were you doing that you saw a couple of Zambonis? Okay, so we've got an index buffer. That should be the indices into the vertex buffer. So I think now we should be able to just do Lloyd.add vertex and then we need our vertex from the vertex buffer. Dot indices dot get I, probably. I'm just kind of pulling this all out of my ass, so I have no idea if any of this is actually going to work, but we're going to hope. Okay. Now we can build that object. Yeah, I mean, we're usually kind of flying by the seat of our pants here. Alright, so we're just gonna hack this straight into the render buffer, or into the render engine. This dot Q model, and we are going to Q Lloyd. We are going to use the EMD renderer. No, I guess we should just be able to use the standard renderer. And we're gonna want some transforms too, so we can move them around. We're gonna leave that as identity for now. Alright. We're gonna see what happens here. Very appropriately ominous music. It's probably just gonna crash. It did in fact crash. Alright. Why did you not load anything? Okay, so it is lloyd.dae. We're just going to copy and paste this. It may want an absolute path. Thank you, chocolate. We're going to do path equals path dot of lloyd.da to absolute path, and then to string. We'll use the absolute path and see if that helps. Drop a breakpoint here just so we can see it. No, scene is still null. Okay, let's check out the documentation here. Path and file name of the file to be imported. So let's just make sure that the system thinks that file exists. It does. The file is there. It is getting this extra, this directory // so let's remove that and see what happens. No, scene is still null. So what is going wrong here? Do we have any errors? Get error string. Invalid data index 51/18 in primitive specification. So this model is actually broken. So we can... Icarus, are you still here? That is very interesting. What was that again? Does this model work for you if you import it into Blender? You can import it into Blender. Okay. Invalid data index 5118 in primitive specification. I have no idea what that means or really how to track it down. No, I'm not using textures right now. Yeah, give me a GLB. Or really, like, anything, honestly. You could even send over an obj or something. Ready? You want to sit on your donut? Oh, jeez. Donut is going down. Ryder, come get on your chair. Ryder has come to join the stream. Ryder has arrived. Ryder is the big baby. The biggest baby. Look at the size of this baby. Oh, he's stuck in my sweater. There you go. Alright. Alright, Icarus has sent me a GLB file. I don't know what a GLB file is, but we are going to hope for the best. Okay, that worked. We seem to be in business. Let's just step through this a little bit. How many meshes do we have here? We should... Yeah, so we have 14 meshes. And we get faces. That is good. We get vertices. Also good. Yep. We have a vertex. We have a vertex with values. Now these are very, very small. They are likely normalized vertices. So I think this is going to be extremely small. We may have to scale them up a lot, but that's totally fine. Okay, so let's go to where we're queuing, and we're gonna say Lloyd transforms dot translation. Our translation, we'll just do 100 units. Actually, let's not do a translation on the X or Y axis yet. And we are going to give it a translation very close to the screen. And give it a scaling factor of, I don't know, 100 for now. Okay, not seeing anything. Oh, we didn't reload. Duh. But still nothing. Why are you failing to break point there? Hello, Strider. Hello. I'm not sure that this is actually updating properly, so I'm gonna just restart it. Oh. Alright. We definitely have something rendering. Let's scale them up by another 3x. Hi, Strider. Hi, buddy. All right. So this is a start. And actually, I think I do want to use the TMD renderer so that we can give it lighting. So I'm just going to copy and paste this. Not sure if there's any lighting enabled on the on that scene. Let's just load up a save. All right. So we've got something. Hi, Strider. Hi, buddy. Hi, buddy. However, I think at this point, the lighting has probably already been reset. So let's take a look at somewhere else. Okay, so for now, let's close this, and rather than rendering here, I'm going to make these properties of the render engine. We're just gonna do this real hacky like. Just a giant blob crashing through the mountains. Okay, alright. So, yeah, it just occurred to me, the reason lighting's not working is because, we need to pull in the normals. So let's take a look at that. So, yeah, we've got normals here. Normalized vectors. The array is some vertices in size. Normals are undefined for point and line primitives. So if there's number of vertices, this should just match the vertex buffer. Normals are basically a way for the render engine to know which direction a face is pointing. We don't have normal support on here, so I'm just gonna add that real quick. I believe these should be the normals here. Let's just look at the TMD object loader. Position, yes, and then normal side. All right. So to our vertex class, we will add a normal vector. And this dot current dot move dot set XYZ, and then we just return this. And of course, we need to load those normals. Grotto, you know you can lay down, right? Maru would be pretty damn funny with the Dragon Buster. Okay, let's see what happens. Okay, so doesn't look any different. What's up, J-Man? How's it going? Thank you, Hackradin. Lego LOD would be pretty damn great. He's just standing on me and leaning up against my chest. Okay, so we do have normal values. These look alright. Yeah, he's pretty cute. Okay, we are normalizing those, so these should be normalized normals, which is what we have. This appears to be correct. I wonder if it's just because we're creating it as all white. What happens if we step this down to 0.5? No, we're still not getting any shading here. Yeah, I mean, I try. I definitely try. Working with the LOD engine, it's not always easy. We have made very, very large strides in cleaning up the code base and you know, just converting it from basically like walls and walls of code to like something manageable. So what are we missing here for lighting? We have the light direction, light color, presumably these are set as expected. I believe that should be happening, yeah. That's happening back here. Yeah, I'm not surprised. Banking and financial is a goddamn nightmare. Yeah, so that is as expected. Right. Yes, you're very cute. Very, very cute. We are loading the normals. Oh, we need the lit flag as well. Right. We have all of these flags, and these tell the render engine what features it should be enabling when rendering this. So we're going to set the lit flag, and we're going to reload and see what happens. For Remember, chat, there's only so many things that can be wrong. Oh, I forgot I have a breakpoint here. Okay. So we do have some semblance of lighting here. Now, keep in mind, so LOD doesn't have T-poses. Models in LOD are kind of just, like, blobbed together. So you're just kind of seeing, like, random parts of Lloyd's model all sitting on top of each other. Icarus, when you open this model in Blender, is it just one part that is the sword? And if so, which part is that? Yeah, let's check it out in FreeCam. Good call. Oh, right. FreeCam is super fast in the world map. Yeah, I think we can pretty clearly see which part is the Dragon Buster. Actually, yeah, if you want to just send me the Dragon Buster, that would be even better. That way I don't have to pull out the specific part. Just send the Dragon Buster on its own, yeah. Yeah, I mean, this is definitely working, definitely rendering in the render engine. So that is an excellent start. Yeah, they basically do get folded into a box. By the way, in case anybody is wondering, we are currently listening to Lloyd Sorrow's renditions of the LOD soundtrack. He is currently working on remastering every single one of the songs in the LOD soundtrack, and it will eventually be released as a mod for Severed Chains. Alright. We've got that, and Lloyd's texture, which should contain the Dragon Buster texture as well, is going to be in here somewhere. Icarus said Dragon 0561. Are there loose textures just sitting in this folder? I mean, I wouldn't be surprised, but damn. Yeah, that's a texture. Let me see if he's done the battle music yet. I'm not sure if he has. Yeah, I don't think he has yet. He's got like probably 15 or 20 songs done. I've just got them kind of shuffled right now. Yeah, no rush, Icarus. I'm just working on the texture here. Let's just pop it open, take a look at it. First things first. Boy, that is small. And there's no way to zoom in this program, so I am literally going to take a screenshot of it and paste it here. Alright, presumably this is some of the effects for the Dragon Buster. We have not modified any of the game textures or models or anything like that. It is all using the original assets. However, our rendering engine is much, much better. So all of the models, animations, textures, and everything like that, they look much better. Now this is the world map, so it's fairly low quality, but you can actually see all of the details that they included in everything, unlike in retail. Alright, Icarus has sent me just the Dragon Buster. So we are going to save that and just load the Dragon Buster. See what this looks like. Yeah, they're definitely doing VRAM animation to get the scrolling effect. Okay, so let's raise this into the air a bit. Okay, where did it go? Was that too far into the air? The units on the world map are a little weird. If we just do -1. Okay, that did move it quite a bit. Oh, I think what's happening is that the order that we are doing this in, yeah, the scale is getting applied, and then the translation is getting multiplied by 300. Yeah, that's exactly what was happening. Cool. So we've got a Dragon Buster, we've got lighting applied, we've got Strider spinning around in circles. There is a mod that is in the works, the upscale mod, and they are working on upscaling all of the textures in the game, but that is not part of the core severed chains. Alright, so here is the untextured Dragon Buster. Strider, you are sitting on my headphone wire. It is just completely wrapped up in your legs. Alright, buddy. You gotta chill out. You gotta chill out. Now, the question is, can we get it textured? Oh, here we go. Headbutting me in the face. Yeah, so I have no idea which parts of this are for the Dragon Buster. Interestingly, it looks like this is MIP mapped, but like backwards. Like you've got this as like texture, and then it's repeated here, but at a quarter of the size, then it's repeated again here at the quarter of the size, and again here. That is super weird. You sure this is the right texture, Icarus? Yeah, personally I prefer the original graphics. But definitely a lot of people are very excited for the upscale project. Alright, so now we need to figure out how to pull the UVs. So presumably, yeah, so we've got the UVs here. Specifies the number of components for a given UV channel. Up to 3 channels are supported. UVW for accessing volume or cube maps. The value is 2 for a given channel N. The component P.Z of texture coordinates is set to 0. Okay. We've got texture coordinates here. Yeah, the textures and models are like way more detailed than the PS1 would ever be capable of. So we're kind of like, it really benefits us because, you know, the game looks so much better in Severed Chains than it does on emulators or anything like that, because we can show that detail much more clearly. Okay, so Icarus is not sure that that is the correct texture, so let's just pop into the oof cutscene and see what's loaded. You know it's the right save because Lavitz disappears. What's up, Matthew? I am not sure if they use the same model as they do in the Lloyd fight or not. They often do like load much more detailed models during cutscenes. Okay, so we've got Dragon Buster here. So let's jump into the render engine. Now of course, question is, which one of these is Lloyd? Is he still loaded? I don't think he is. We're having a bad time with the free cam right now because we've got this frame buffer effect up. There it is. There's a blur on this scene, which is why you're seeing that. Okay, here we go. Blur is gone on the next frame. Whoops, I keep pressing F12 and unpausing instead of pressing, or F11 and unpausing instead of pressing F12 to open the debugger, which is already open anyway, so I don't even need to. Okay, so combat debugger. Right, he is not loaded as a combatant. We should have some. We've got 3 battle entities here. Icarus, I don't suppose you have a good way of checking which one of these is Lloyd. Not necessarily, because it entirely depends on what order they loaded them in the script. So we do have quite a few battle entities loaded here. Oh, the VRAM viewer does not render when we are paused. Okay, I just took a screenshot of that. Lloyd is missing his cape. We have broken... Oh, right. No, he doesn't have a cape in this part of the scene because you can't actually see behind him. Now, we are looking for something that looks familiar. So, this right here, this has that same repeating pattern as Lloyd's texture that we were seeing here, right? See how it's got that L shape and then like a smaller L shape with this same general, like if you see this, that matches this thing protruding down here. If we go even smaller, you can see that there too. So I am thinking like this texture is definitely loaded. And this does look like it would be used for the Dragon Buster effect. Yeah, interestingly, we've got several of these textures that seem to have that MIP mapping. Like you can see this and it's repeated here, smaller and then again smaller. But MIP mapping is never actually used in LOD, so I don't know why. Yeah, this is a view of the raw VRAM, Garrett. We're looking at it in 15 bits per pixel. but a lot of the data is loaded at 4 and 8 bits per pixel, so it's compressed. And we're actually looking at multiple pixels jammed down into, like multiple pixels jammed down into 1 pixel. But that being said, this does not match. Let's compare. Let's compare. This right here, this might match this. You see that kind of general shape? However, yeah, no, this stuff below it does not match. A little too quick on saying that this was definitely it, because it's not. It just has the same mip mapping shape. Looking at the left side of these textures. Also, so the way that we're looking at the raw VRAM of the PS1 right now. So basically this is like it's the memory of the actual like GPU. So the way that the GPU memory is divided up is into something called texture pages, and those are well, the full VRAM is 1024 by 512, 1024 wide, 512 tall, and it's divided up into what are called texture pages, which are 64 pixel wide by 256 pixels tall. So each of these rectangles, so like this would be one texture page, this would be one texture page, and so on, so on. And for the battle entities, they split those up into 2 slots stacked on top of each other. And we call those, we just call those texture slots, because it's basically what they are. So we need to figure out which one of these textures matches this, if any. And it may very well be none. This is not guaranteed to actually be the correct texture. Now, I'm seeing this protrusion here. I don't think this matches. These tiny squares below, these are actually the palettes. So these are not the like full texture. The way that 4-bit per pixel or 8-bit per pixel color works is that the texture does not actually have like the real color for the pixels. I'll just illustrate this real quick, it's much easier. What are you doing, Paint.net? Are you seeing this flicker? You good? Okay, not doing it now. Anyway, so they will have a palette. So you can look at this palette right here, and we can say, for example, like this row might be the palette for the texture. So instead of drawing something like using these colors, the colors would actually just be like instead of like, for example, this color might be like 255 red, 0 green, 0 blue. We can see the actual like hex code for the color if we click on it here. So it's 255 red, 0 green, 0 blue. That is 3 bytes worth of data. However, if we are only using a limited number of colors, we don't need to store that whole number for every single pixel. We could just say, like, everything using this color is using color 0. And then, aside from the actual, like, image data, we can store just a little bit more data that says, if the pixel is using color 0, then it's using this value here, FF0000. So if we only use 16 colors, for example, we can store that in 4 bits. So we can actually store like 2 colors per byte rather than storing 1 color in 3 bytes per pixel. So it is like 1/6 the size, but you have a serious limitation on the number of individual colors you can use. So it's a trade-off to be able to store like much more data in the very limited amount of VRAM. PS only has 2 megabytes of VRAM. So can't store a whole lot of stuff in there. Alright, bye Strider. What's up, Leningrad? Yeah, so like, these would be the different palettes that belong to the texture directly above it here. Anyway, that was a bit of a tangent. Let's get back to this possible fool's errand. Yeah, I'm not sure that this texture is actually loaded here. Yeah, so this whole thing is the texture page. And I'm not seeing anything that resembles that here, and I don't think we have model textures loaded in the upper portion of VRAM. This is UI stuff. That's the letters. More letters. Yeah, I'm not thinking that it's loaded here. Understandable. Let's see what we can find here in the file loading log. And we don't care about any of these scripts. Maybe we should... Ryan, let me just send Drew a message here. I'll make sure that your email gets responded to. We can definitely get your save updated to 50 Stardust. Yeah, we're kind of in like a weird intermediate state with the graphics in Severed Chains at the moment. See, a lot of it still uses the emulated VRAM, so basically all these textures are getting like packed into one texture in the same way that LOD would load them into the VRAM of the GPU. And that's just because it's much, much easier for us to get everything working in that way, rather than loading them into like individual OpenGL textures. That would have like extended this release cycle by probably like a year, trying to get everything to work properly and getting the texture animations and everything working properly. We do, however, support like using OpenGL textures like normally as well, but for everything that just renders like in the standard render engine, it just uses that one like packed texture. Blade has vertex colors. Hilt seems to use Clut 11. Alright. Let's just abandon this for now, and we will pull in the vertex colors and see how those look. So again, we are going to have colors. Good morning-ish, Zychronics. I know your time zone. Now, it actually is morning for Leningrad. Okay, so this is going to be the same as the others. One per vertex. So this is a pointer buffer. It would be nice if it told us what the pointer buffer mapped to. We have like a AI color, we do. Icarus, do you know if these are three-dimensional colors or four-dimensional? Alright, we're just gonna see what happens. I assume we can just do that. RGB, and we're going to pass in B. And let's take a look. It did not like that. It did not like that at all. Null pointer exception. Maybe the pointer will be null if there are no vertex colors for that vertex. Color pointer. We'll split this. Color pointer is not 0. Then we create that. Else it is null. And then we will only set the color if the color is not null. So let's just take a look here and... Oh wait, hold on. No, it said that there's one color per vertex. So we're going about this wrong. This needs to come into here. And that's gonna be vertex index. This is also vertex index, and this will also be vertex index. We no longer need this. We can do this. And let's try that again. Okay, so we are definitely getting... Yeah, okay. Okay, index out of bounds. Did that not say that each array is number of vertices in size? That doesn't make any sense. Okay, let's take a look at what our vertex indices are. So vertex index 0, 1, 2, 0, 2, 3, 4, 5, 6, 4, 6, 7, and then we have 8. The limit is 8. That does not match what the documentation is saying. See, there's 197 vertices. And the documentation says each array is number of vertices in size. And if we look at the number of vertices, we get 197. So... Okay, hold on. How many meshes do we have? 1. Okay, I think this is actually per mesh. And... But why would there be 8? There'd be 8 different ones. Something weird's going on here. Okay. Let's look this up. Each mesh seems to have a possible maximum number of colored channels associated with it. That is expected. Okay, so they're calling has vertex colors on the mesh. We know that this does have vertex colors already. We're not going to worry about that. So number of vertices. So they are just looking up the mesh and... Okay, they are... Okay, so they're using a two-dimensional array here. And this is the worst thing I have ever read. Okay, so we need to read from a color set. So it's two-dimensional is the issue. We first need... So do we have AI color dot buffer? We do. Okay. This has to be it. Now, of course, the question is how the heck do we get what we want? Because there is basically no documentation here whatsoever. What is this? Okay, so that just returns a buffer. Okay. That should work. I think that'll actually return the buffer that we need. It does not. What are you... Oh, wait. No, still not. Okay, it's 40 colors, and... There we go. Okay. Hopefully this will work. Okay, I mean, it's something. We definitely have colors. It's real yellow. Yes, it is the banana sword. Yeah, Icarus is saying that the vertex color may not actually be something generated by Doom's tools. Let's take a look at what we've got here for colors. I mean, Icarus, I would assume that Doom's tool does export colors, because that is a major part of a lot of the models. Like many of the models are untextured and rely entirely on vertex colors, right? So if it didn't output the vertex colors, then it would not look good at all. Very dramatic pony, bro. Yeah, I mean, all these colors that I'm seeing so far at least are either gray or black. Oh, okay, here we go. We've got some actual colors here. That's gonna be... Oh, actually, I'm still looking at the Lloyd one. Oh, and you sent me GLB. That's a compiled format, isn't it? Yeah. That is unfortunate. Yes, that was XML. That was the DAE file format. Let's take a look at what we're getting for colors here. Yeah, about half red and green, and then a little bit blue. Oh, 9. Oh, 9. 25. Yeah, so I mean, it's kind of like a sickly greenish color. No, that's definitely not the format for LOD's 3D models. I just now wrote this importer for it. LOD uses the standard PS1 format, TMD. It does have another model format that it used to use, which was like a proprietary format that they came up with for the game, which was very similar to TMD, but a lot of the data was compressed. However, when we unpack all the game files, we just convert all those to regular TMDs. Let's see if maybe it is maxing out on these colors. I don't think it should be, but let's just cut those in half and see what the colors look like. And for textures, they use the standard PS1 TIMA format, but they also use a custom format called MCQ, which again is fairly similar to TIM, but not. That's what the background texture here is, like this map texture that you can see in the background, that is an MCQ, as well as like the skybox textures and stuff like that. They support greater colors than a regular TIM, because like I think it's 16 by 16 pixel section has its own palette. But yeah, it's kind of a weird format. Where the heck did land go? Okay, so yeah, we're still getting this kind of sickly color, which, I mean, that color at the top is very close to what we were seeing when we loaded that color into paint.net. Yeah, so the reason that Icarus sent me the model in that format was because that's the format that the tool that Doom Metal is working on for converting models outputs it in. However, for whatever reason, it was not loading properly, so he converted it into a GLB format, and that's what we're using now. And the reason that he did that is because he wanted to edit it to pull only the sword out of Lloyd's model. Okay. So, vertex colors may be a bust. So let's see if there's any other color sets here, just in case. Yeah, all the other color sets are null, so it is just the one. And no sidetracking. Just getting this working is proving to be somewhat difficult. I mean, we could just take it as is for now and work with what we've got. I think that's what I might do. She's gonna have a banana sword, but we'll all know what it is. Okay, so where do we start? I think so the player battle entity, this is actually very, very convenient. I've already got this method here that specifies which model part is the weapon. So we can turn her weapon off, and okay, first let's try turning weapons off. So there should be a render callback. Okay, so I am going to add a function here. Hopefully this doesn't break anything. Oh, actually, no, we can just do it right there. That's perfect. They are already doing what I was going to do. We'll make this protected, and we will go into the player battle entity, and we're going to override that. Loaded. Thanks. So model and should be invisible, and we are going to OR the bit flag. This dot weapon model part. And I think this should make everybody's weapons invisible. Actually, that could be above 32, so that should be a long. Alright. So let's jump into a battle here. Okay. So everybody is missing their weapons. That's not something that you see every day. Gonna take a screenshot of that for Discord. Okay, so this is so far working exactly as we want it to. So now we get into the math. Okay. So this dot model dot parts. So we've already got a local coordinate system for the model part itself, and it should already be bound to the battle entity's coordinate system. So we might actually just be able to use this for the rendering. So I'm also going to override the render method. So Q model, and we're going to use, we have stored that as a static on the render engine for now. And we are going to queue it as a TMD because we want to be able to give it lighting, obviously. Which we can just copy from here. Now the lighting is already... No, the lighting won't be set up. But we can just grab this stuff. We don't need... Okay, so we'll need the local world matrix. That should be all. That's gonna be this dot model parts. This dot get weapon model part. Coord 2, that's the local coordinate system for that part. We need a matrix for the local world matrix. We do not need the local screen matrix. We can just use LW. Back to battle model. So we are going to need the depth offset. Yeah, that should be everything that we need, I believe. Yeah, okay, so that is what we expect. This all looks good. And for the transforms, we're going to want the local world matrix. Now, I am thinking this is not going to work right off the bat because it's going to be extremely small. I think we're going to need to figure out a good scaling factor for these because the outputted models are at a very different scale than what LOD's models are. Yeah, I think it's pretty likely that we just won't be able to see it at all, if it is even rendering. Yeah, I'm not seeing anything there. It could be like embedded inside of the hand or something anyway. If I was to just scale this up, this may or may not work. Let's try a scaling factor of 100 for now. I'm seeing something yellow in Rose's hand. That is a good sign. Yep. Okay. We have the Dragon Beater from Disc 1. Okay, so it's actually rendering. Honestly, I'm kind of surprised by that. It is actually a banana. 200 scaling factor, probably still too small. Yeah, let's do 500. Alright, now we're talking. I think they need to be rotated on either the X or Z axis, depending on which way we are oriented. Because Dart's sword should be 90 degrees rotated counterclockwise here. For sure. Let's try rotate X. Pi. That may have been the wrong axis. Oh, so sorry, it should have been half pi, not full pi. Yeah, I think that was the wrong axis. Let's try Z. And I think we're just rotating in the wrong direction now. There we go. I mean, that looks right for Dart, does it not? Rose, you good? You good? Okay. Clearly not correct. But anyway, let's try an attack with Dart and see what happens. It's definitely still a little small. We gotta jack up the size a little more. Let's try a 600 scale factor. That's a little more reasonable, I think. Alright, gonna grab another screenshot. The dragon banana. Yeah, once we do, we can definitely do like a size comparison with like something in game and just get like a constant value that we can multiply with when loading things. And that should just do across the board. Wee. Dart, I don't know how you just pulled off that little spin in midair, but you know, good on you. Okay, so Now, why is the math right for Dart and not for everyone else? I'm assuming also it's, he's holding it angled towards himself, which obviously is not correct. So I'm thinking the rotations may be interacting with the other rotations. Yeah, rotations in 3D on multiple components are complicated, to say the least. Rather than rotating after the fact here, I think we should be able to do something like this. Adjust the rotation on the rotation vector in the coordinate system. No idea if this is the right axis. What did that even do? Nothing? Huh? I think for one thing... Yeah, okay, so this is not being updated at all. So we are actually just continually decreasing this. Alright. Let's end this battle and start a fresh one. And damn it, I didn't comment that out. Okay, let's end this battle and start a fresh one. And first off, I want to see what these values are. Okay, so they are constant. So what happens if we just do that? True. That didn't seem to do anything. Nor did that. Okay, so why are these transforms not getting used? Let's... I wonder if it is... Oh, I bet I know why. It's probably using the cached matrix. After we change this, we need to set the flag to something garbage. No? Come on. Okay, so this is the method that assembles the coordinate systems. Oh, it is... Right, after these are updated, we need to actually update the transforms. I just need to remember how the hell to do that. Hopefully something in one of these methods is going to... Come on. Something has to be... Here we go. This'll do it. Yeah, I'm just gonna copy this out. Okay, recompile. Okay. So we do have actual rotation now. Now here's the thing, I only want to change the rotations once. So we'll do that when it's loaded, and we're going to subtract half pi on the x-axis and see what happens. Okay, so it does look like it's getting reset now. So the transforms, what do the transforms look like? Set to pi. Okay, I'm not 100% sure if this is actually going to work. Let's just reload the battle. No, that's the same as it was. What are our transforms looking like? Okay, transforms are definitely updated, so I think if we simply move this here, we should get something. Now, why is that changing it for everyone? I want them to hold it in the same way that they would be holding their weapons, just rotated correctly. See, they are holding... They're holding them correctly, except they just need to be rotated by... Like, this should be up here. Darts was correct, but Rose and Albert weren't. I'm not sure why updating the matrix is doing this. Okay, let's take a look at the load TMD. Let's take a look at this. Why? Where is the class that loads these? Yeah, well, the thing is, I'm not sure why just updating the matrix like that is causing them all to point in the exact same direction rather than being rotated from where they were. Yeah, so I mean, like, we're just taking the parameters that we had set and applying them to the matrix. Okay, let's step back here a little bit. Yeah, I know that the rotation was... It was right aside from the rotation. However, like, all I'm doing now is applying the rotation. Because otherwise it's not... It doesn't get set. Like, if I comment out where we're actually setting it, then it is correct, just not rotated correctly. But it seems like simply applying the rotation that we defined shouldn't... Like, okay, so let's take out where we're actually changing the rotation entirely. And reload the battle. Yeah, okay, so there's something funny going on here. It's like this matrix is not actually... like being used or being updated or something? See, if we look at the rotation vector, everyone's is set to the same thing. I'm wondering if the animation code is just not... apply model. No, animate. So if we look at the animations, okay, so the rotation is not actually being used there. It only uses the quaternion that is calculated from the animation here. So I wonder if we can just adjust the quaternion. First off, let's boot back into battle so we can look at these things that are happening. Okay, adjust camera angle. What do we have? Okay, yeah, that's probably the best. So if we come in here, the corner 2 transforms. We got this quaternion and I wonder if the quaternion is getting updated each frame. Let's just grab a quick screenshot of these values. Gonna paste them in there, and I'm just going to rotate X by half pi. And we are going to proceed to the next frame. Let's just make sure which... Yeah, so we are looking at Dart right now. Let's proceed to the next frame. And... core2.transforms.quaternion, and it did get reset. That is what I was hoping for. Now, if we look back to this code here, and if we just copy this, and we rotate the quaternion by half pi. Nailed it. But why? Did we not check and see that this is the same? It is the same. Do we need to clear the flag? I can't see that being it. No, that did nothing. So the weird thing is, the quaternion seems to be getting reset each frame. But then when we... Okay, so let's look at these values. 611. And... Okay, it is different. This dot element, let's... Okay, we're looking at Dart. We are looking at Dart again. Quaternion is 611-100-408. Okay. Cycle back through. We are looking at Dart. quaternion is different. Why? Let's look at it before it gets changed. Make sure we're looking at Dart. We are. Quaternion is 501361. That is different. Five oh one three six one. Yeah, so why is it switching back and forth? No, that is slightly different. Now, I mean, it is entirely possible that this just cannot be done at this state because I don't think that the math is commutative. What happens if we pre-multiply? It is not better. Everyone is still spinning their bananas. What kind of exciting things happen if we do it on the z-axis? I am confused about why there seems to be two different quaternions. Let's just check and see what... Okay, this is hash 9805. And it's still 9805. Okay, so it is the same quaternion. If we look at the model here, it must be that it's because it's switching back and forth between the main frame and the interpolation frame, right? Yeah, so I think the issue is we just can't do this after the rotation has already been calculated. It's just not a thing that can be done. So we need to do it as part of the animation, but that is really complicated. The animation doesn't actually take into account the rotation of the part itself. It sets the quaternion directly from the animation. So... and the quaternion is... The issue is that the model is just not oriented correctly in the first place. Like the previous, like what it looked like before, if we just revert all of this. Like the issue is just straight up that this model is rotated differently in the file than their weapons are. What do you mean by hollow weapons? You mean like no weapons at all? I also don't think that the normals are quite right, but that is an issue for another day. Where it flashed between poses. That's just me applying this. Yeah, I mean it's... I think it's just backwards at the moment. Well, no, Rose is still holding her sword incorrectly. The other two are right now. Or no, does Rose hold her sword down? That doesn't look right, though. No, she holds her sword up. Alright, so what I'm gonna do... I want to try something here real quick. So we're just gonna do a little bit of hacking. On this transform, we are going to add a new vector. And we are going to have to get rid of this optimization where we pre-calculate the quaternion, which is unfortunate, but not the end of the world. Rams.quaternion.rotation XYZ. And that's going to be... Okay, so let's grab the keyframe. And we are simply going to add the vectors together in the animation code. And we need to do the same thing in the interpolation code as well. And this is just going to be quat. And then instead of using the quaternion from keyframe, we just use the one that we built there. Okay, so I think this is what I want here. So in the animation code now we have this extra vector. That is just a flat amount that we will add to the rotations. And we can initialize with some values and then basically not worry about it after that, I think. Okay, let's see what happens. Also, I realized I've been blasting out double music, so I'm just gonna go ahead and mute the game music. Okay, so we have actually maybe the right thing? No. Damn it, Dart. Why is everybody else fine except for you? I do think we also need to rotate on the Z-axis. I think if we move this here, it might be fine. So that definitely did not do the trick. That might have. Okay. I think we got it. All right. Time for another screenshot. Yeah, I think that is just the way that their weapons are rotated. Like, that is the way that he is supposed to hold it. Alright, so this is the first real-time weapon replacement that has ever been done, and it is fully functional. So let's just buff up this mouse a little bit. What's up, Sato? We actually just got it working. Okay, rotation is definitely weird when attacking. I'm not 100% sure why that would be. Also, oh, that just procced instant death. because Rose has the instant death weapon. I was like, how in the hell did I already do like 2 billion damage to it? Yeah, Rose definitely looked better than Dart. Albert's is also a little derpy. You can see that the weapons don't disappear when the player models do during additions, so they're still just floating there. The weapon trails are correct. It is definitely the model itself that is not correct. And it's probably because of the rotations that we're jacking in. I think that we should probably just like fix the rotation in the file. But anyway, this is just a prototype, obviously. Just kind of proof of concept to say like, we can do this. Alright, there you have it, chat. Very first full weapon replacement that is not just a 3D model edit. Yes, it is the Dragon Buster model. We are just kind of prototyping weapon replacement. Yeah. I mean, at least when they're standing still, everybody's holding their weapon correctly. And it'll just be a matter of getting all the math to work out properly. I think the normals are also not quite correct because the lighting definitely does not look like it's being applied properly. The normals might also be rotated incorrectly or something, but anyway, like I said earlier, there can only ever be a finite number of problems, so it's just a matter of working through the list and fixing them one by one until it's all working perfectly. But with all that being said, I think this is where we will wrap it up for tonight. Honestly, I'm kind of surprised we actually, like, you know, got this working as well as it is. I figured it would at least take a couple of streams to get it going, but, you know, here it is as a very, very basic prototype, obviously. But it's looking pretty good, and, you know, this is only the beginning. Yeah, I think we will be doing the live stream on Sunday. I haven't heard otherwise. I don't think Liv is working, so we'll get that scheduled either tomorrow or on Sunday. And yeah, make sure you tune back in on Sunday to see my wife's very first playthrough stream. She has somehow lived in the same house with me for the past 4+ years that I've been working on this and did not get a single part of LOD spoiled. So she's doing her very first completely blind playthrough right now. We're doing that every Sunday. And normally I do the dev streams, not today, I normally do them on Wednesday. So also stick around for that. Make sure you subscribe to the channel if you definitely don't want to miss those. Recap of tonight, so many bananas and a lot of rubber ducking. That pretty much sums it up. And yeah, excellent cats. Alright everybody, if you like what we're doing here, make sure you subscribe to the channel so you don't miss any of the streams. We also just added a new role on Discord. So if you jump into our Discord server, you can give yourself the stream pings role. And every time that we're about to start a stream, we will ping that role so that you don't miss it. Drop a like on the video, and if you really like what we're doing here and want to support, LOD, Severed Chains, and me, Liv the Cats, there is a donation link in the bottom left-hand corner. You can send a one-off donation or subscribe monthly for various perks that I've got listed on there. Have a good night, everybody.